Hello everyone. Today I am Rishabh Bhardwaj, Assistant Professor from the Mechanical Department, taking the lecture of Automobile Engineering. Today I am taking the lecture on the topic that is air brake system. This is our 19th lecture. Let's start with the air brake system. What is air brake system? To know about the air brakes, initially we have to study about its history, from where and who had made this development and when. Let's start with this. Initially, this fail-safe air brake system is based upon and had been patented by George Westinghouse in 1872. An air brake is a convenience brake system caused by the compressed air. After the 1872, by using the air braking system, bakers used to brake the wheels. The importance of safety in the relative new railroad industry and invented the first triple valve air brake system for the railcar use. Westinghouse system works the opposite way of direct air brake system. Next, we will start with the introduction part of this air brake system. A air brake is a device by means of which the artificial resistance is applied to a moving or in order to stop or slow down the motion of the body. The brake applied with the help of air pressure are called air brakes, and the system causes its call as air brake system. In this, three processes are done. The first one is the charging. The system must be pressurized with air before the brakes will release. At rest, the brakes remain engaged. When the system reaches its operating pressure, the brakes are freed and ready to use. Second process is applying. As the brakes are applied, air pressure decreases. As the amount of air decreases, the valve around air back into the reservoir tanks, while the brakes move to the applied position. Third is releasing. Once the brakes are applied and air escapes after braking, the increased pressure releases the brakes. Let's move to the working and principle of their action. Instead of using the force or direct air to apply the brakes, much like hydraulic fluids in the car, the triple valve fill a tank and uses air pressure to release the brake. In other words, the brakes in triple valve system remain fully engaged until air is pumped throughout the system. In the air brakes, simplest form is in which the compressed air pushes on the piston in the cylinder. The piston is connected through mechanical linkage to brake shoe that can rub on a train wheel using the resulting friction to slow the train. The mechanical linkage can become quite elaborate as it evenly distributed force from one pressurized air cylinder to 8 to 12 wheels. Next, we have a types of air brake system. The air brake system is mainly classified into three types, and the three types can be classified, and the base of the method and design development Now first we have a straight air brake system, second Westinghouse air brake system, and third is modern system. Let's start with the straight air brake system, in which the compressed air pushes on a piston in a cylinder, and the piston is connected through the mechanical linkage to brake shoe that can rub on the train wheel, using the resulting friction to slow the train. The mechanical linkage can become quite elaborate as it evenly distributes force from one pressurized air cylinder. The pressurized air comes from an compressor in the locomotive. These types of brakes are generally used in the trains. Next we have a Westinghouse air brake. In the Westinghouse air brakes, in order to design a system without the shortcoming of the straight air system, Westinghouse invented a system wherein each piece of railroad rolling stock was equipped with an air reservoir and triple valve, that is also known as control valves. Unlike the straight air system, the Westinghouse system uses a reduction in air pressure in the train line to apply the brakes. The triple valve is described as being so named as it performs three functions: the charging air into an air tank ready to be used, applying the brakes and releasing them. It supports a certain other action. In this Westinghouse refer to a triple valve device used of the three component valvular parts comprising it the diaphragm operated puppet valve feeding reservoir air to the brake cylinder, the reservoir charging valve, and the brake cylinder release valve. The Westinghouse soon improved the device by removing the puppet valve action. These three components become the piston valve, the slide valve, and the graduating valve. If the pressure in the train line is lower than that of reservoir, the brake cylinder exhaust portal is closed and air from the car reservoir is fed into the brake cylinder. The pressure increased in the cylinder applying the brake while decreasing in the reservoir. This action continues until equilibrium and between the brake pipe pressure and reservoir pressure is achieved. At that point, the air flow from the reservoir to the brake cylinder is lapped off and the cylinder is maintained at a constant pressure. If the pressure in the train line is higher than that of reservoir, the triple valve connects the train line to the reservoir feed, causing the air pressure in the reservoir to increase. The triple valve also causes the brake cylinder to be exhausted to the atmosphere, releasing the brake. As the pressure in the train line and that of reservoir equalize, the triple valve closes, causing the air in the reservoir to be sealed and the brake cylinder is not pressurized. When the engine operator applies the brake by operating the locomotive brake valve, the train line went to the atmosphere at a controlled rate, reducing the train line pressure and in turn triggering the triple valve on each car to feed air into the brake cylinder. When the engine operator releases the brake, the locomotive brake valve port to atmosphere is closed, allowing the train line to be recharged by the compressor of the locomotive. The subsequent increase of train line pressure causes the triple valve on each car to discharge the contents of the brake cylinder to the atmosphere, releasing the brake and discharging the reservoir. The Westinghouse is fail safe, or any failure in the train line include a separation of the train, while cause a loss of train line pressure, causing the brakes to applied and bringing the train to a stop, and thus preventing a runway train. Let's move to the next, that is a modern system. The modern air brake system or serve two functions. That is the first function, that is the service brake system, and second is the emergency brake system. The service brakes which applied and released the brake during the normal operation. The emergency brake which applied brake rapidly in the event of brake pipe failure or an emergency application by the engine operator. When the train brakes are applied during normal operations, the engine operator make a service application or a service rate reduction, which means that the train line pressure reduces at a controlled rate. It takes several seconds for the train line pressure to reduce, and consequently takes several seconds for the brakes to apply throughout the train. In the event of train needs to be an emergency stop, the engine operator can be emergency applied or emergency application, which intermittently and rapidly went all the train line pressure to the atmosphere, resulting in rapid application of the train brakes. An emergency application also result when the train line comes apart or otherwise fail, as all train will be intermittently vented to the atmosphere. In addition, an emergency application bring in an additional component of each car brake system, the emergency position. The triple valve is divided into two portions. The service portion, which contains the mechanism used during the brakes application made during the service reduction. The emergency portion, which sends the intermediate rapid release of train line pressure. In addition, each car air brake reservoir is divided into two portions, the service portion and the emergency portion, and is known to the dual compartment reservoir. The normal service application transfer air pressure from the service portion to the brake cylinder, while emergency application cause the triple valve to direct to all air in both the service portion and emergency portion of the dual compartment reservoir to be brake cylinder, resulting in 20 to 30 stronger application. The emergency portion of each triple valve is activated by the extremely rapid rate of reduction of train line pressure. Due to the length of train and the small diameters of the train line, the rate of reduction is high and near to the front of the train or near the brake in the train line. Further away from the source of the emergency application, the rate of reduction can be reduced to the point where triple valve will not detect. The application as the emergency reduction. To prevent this, Each triple valve emergency position contain an auxiliary vent port which when active by an emergency application and also locally event the train line pressure directly to atmosphere. This serves to propagate the emergency application rapidly along the entire length of the train. Use of distributed power the mitigates somewhat the time lag problem with long train because of telemetered radio signals from the engine operator in the front locomotive command and the distant unit to initiate brake pressure reductions that propagate quickly through the nearby cars. Next, we will move to the topic or the principal part of air brake system. For the air brake system, we have a driver brake valve, main reservoir, and a compressor. Then a train line, that is a brake pipe. Then we have a angle cock, that will be the coupled hose between the vehicle, and the train line on second vehicle. Brake cylinder, brake block, auxiliary reservoir, triple valve, and exhaust. These are the essential parts or the components of the air brake system by which we are able to brake the systems. We are able to brake the motion of the system. The air is drawn into a compressor and stored in main reservoir at 7 to 10 bar. The compressed air from the main reservoir is distributed along the train throughout the main reservoir pipe. On each vehicle, the pipe is connected through a triple valve to an auxiliary reservoir. The flow of air between the auxiliary reservoir and a brake cylinder is controlled through the triple valve or distributor. The control of the distributor is achieved by the varying the pressure in second pipe called the brake pipe, which is connected to a brake valve in the driver's cabin. The increasing the pressure in the brake pipe cause the brake to release, while decreasing the pressure causes the brake to apply. Now you can see the brake in release position, in which the brake block is disengaged from the wheel. The brake pipe increases in the pressure to discharge auxiliary reservoir and released brake, and the brake air cylinder reduce in pressure in releasing brake. This is the systematic diagram of air brake system on vehicle in releasing position. If we are talking about the applied brake system, at this point you can see totally differentiate that here you can see the complete increased pressure is over here, and the auxiliary reservoir will not able to feed any pressure to the system. While the braking, you can see that auxiliary pressure, the triple valve may get blocked, and the high pressure move towards that, and the auxiliary reservoir provides the air pressure to the piston. That piston moves forward and pushes the brake block to the and make the engagement or contact with the wheel, and the retardation of the vehicle may be possible. This is the main position of the brake while during the application or engagement. Next we have a two pipe air brake system, in which in this the second pipe of two pipe system is the main reservoir of the pipe. This is simply a supply pipe running the length of the train, which is fed from the compressor and the main reservoir. It performs no control function, but it is used to overcome the problem of critical loss of pressure in the auxiliary reservoir of each car. A connecting pipe with one-way valve is provided between the main reservoir pipe and auxiliary reservoir. The one-way valve allows from the main reservoir pipe to top up auxiliary reservoir. The one-way feature of the valve prevents a loss of auxiliary reservoir air if the main reservoir pressure is lost. Next we have the main component and the functions of the component. First we have a compressor. The compressor is the pump which draws air from atmosphere and compresses it on the train. Then we have a main reservoir, storage tank for compressed air for braking and other pneumatic system, feed pipe and braking pipe. This is used to ensure that the brake pipe pressure remains at the required level. Then we have auxiliary reservoir. It is continuously recharged through feed pipe. This ensures full brake force during emergency. In case of leakage in brake cylinder brake cylinder. Next we have a distributor. A distributor is simply a sophisticated triple valve. It is connected to brake pipe, auxiliary reservoir and brake cylinder. Next we have a triple valve. The orientation of the brake on which vehicle is controlled by the triple valve. Let's move to the advantages. The supply of air is unlimited. As we know that the environment is full of air, so the brake system can never be run out of its operating fluid as the hydraulic brakes can. The air line coupling are easier to attach and disattach than hydraulic lines. The air brakes are effective when considerable leakage. Next we have a disadvantages. The whole braking system fails due to the leakage of fluid from the brake lining. Additional cost is required to install this engagement in the vehicle. And third one is it is complexly constructed. Today in this lecture we have covered about the air braking system, which is also known as the pneumatic system. And this is the new in the field of automobile, but generally from the earlier time and very many years ago the train has been installed with the air brakes. Now the trucks and even the cars also has been installed some air brake system or the pneumatic systems, and that will help in our automobile or the carriage vehicle to run and make a effective braking. Thank you for this watching this video and stay tuned for the next. Thank you.